Well, good morning, class. Obviously, I'm not there in person, but I did want to make a video so we keep on going. So welcome to 8.6, something called linear inequalities. And so I know in the Algebra 1 textbook, linear inequalities, they come as the last chapter in the textbook here. So hopefully you covered at least a good portion of it. And if you didn't, this would be a little bit of new information. If you did, this would be review. So let's go with it here. Before we begin, just a little quick note on the homework itself. I did change the homework. I decided to take out 69 out of the homework section. So if you have your sheet of paper of your homework sheet, you can cross out 69, but I do want you to add 65 and 67. 69 kind of took us a whole new direction, which I really didn't want to go in the textbook here, but 65, 67 are actually good practice problems here. All right, as we begin 8.6, I'm going to cover actually two things here. I'm going to cover properties, and I'm also going to cover notation. Those kind of go hand in hand. Once we do that, then we're looking at like basic inequalities. Then we're going to look at something called short notation. Short notation, they only work for bounded functions here. And then let's take a look at inequalities with absolute value, bounded and unbounded, and then eventually let's take a look at maybe one, maybe two application questions here. All right, with that said, let's jam. First, the properties. The properties here, there's four that we have to sort of think about as far as algebra class is concerned, and it's called the transitive property. So, I guess real quick here, how many have notes with you? Raise your hand if you have notes and copied out the notes. Just kidding. Don't raise your hand because I'm not there to see it anyways. So let's go with it here. If you do have notes in front of you, perfect. You don't need to copy this down. If you don't have notes, maybe see if you can copy this, or it is inside your textbook as well. So let's go with it. I want to give you guys an example of each one here. So the transitive property, that says if A is less than B and B is less than C, that means that A is less than C. What does that mean? So the transitive property is an example, looks like this. Let's say 3 is less than 4, which it is, that's good. We know 3 is less than 4. We also know that 4 is less than 5. That's true. We know that to be true. So if that is the case, that means the transitive property says that 3 would have to be less than 5. That's just the way the numbers work out. That's the numbers I've worked out in pre-algebra as well when we're doing it then. So that works. So transitive property, there it is. Then we have the addition of inequalities. And so this says that if A is less than B, also C less than D, if we add the A and the C together, it still will be less than B and D added together. So again, let's go for it here. I'll give you some example here. So I'm going to add an A and the C together. They're the low end values. I'm going to add the B and the D together, the high end values. So good example. Here we go. 3 is less than 4. I agree with that statement. 10 is less than 12. I agree with that statement too. And so the addition of inequality says this: if I were to add the 3 and the 10 together, make 13, that would still be less than if I were to add the 4 and the 12 together, because that will give me 16. There it is, the addition of inequalities. Okay, two more rules. Here we go. Addition of a constant. For the example here, let's say we set this up here. Let's say 3 is less than 4, which it is. What we're going to do is we're going to add 5 each time, or 5 to each of the sides here. If I were to add 5 on one side, 5 on the other, the question is, does my inequality still stay the same? And absolutely. 3 plus 5 is 8. Less than sign because 4 plus 9 is 9, and 8 is less than 9. So there it is, the addition of a constant property. Well, we have addition, so we're going to have to do multiplication as well. So the example here is that C is greater than 0. For this one, if C is greater than 0, the example that I want to sort of lay out is 3 less than 4. All right, you guys can tell that I like 3 and 4 as examples. That was like 5. So let's go with it. So this says if I multiply both sides by 5, the inequality still has to remain the same. So Notice if I multiply the 3 by 5 makes 15. Go over here, that's 15. 4 times 5 makes 20, and the question is the sign still the same? Yeah, if you compare 15 and 20, yeah, 15 is still less than 20. Notice there's no sign change. In fact, there has not been a sign change all this time, except for this little part right here. If C is less than 0, if that's true, we're going to introduce a negative number. If we multiply through by a negative number, this means we're going to change our inequality. Let's see if it works out with numbers. And so you know that if it works out with numbers, then you know it's going to work out the rest of the time too in algebra. So quick example, here it is. Hey, 3 and 4 again. 3 less than 4? Yes, that is true. Multiply both sides by a negative 5 this time. So negative 5 times 3 is negative 15, last time I checked. And 4 times negative 5 is negative 20. And the question is this, negative 15 is less than negative 20, or negative 15 is greater than negative 20? So with negative numbers, I think you guys know this here, negative 15 would be greater than negative 20. So there it is. There is this little concept of whenever we multiply through by negative, we have to switch the inequality, or multiplication actually works for division as well. So if we were to divide both sides by a negative number, we would have to switch the inequality. Okay, we got those properties out of the way. Let's look at notation now. Exercises 1 through 6. I've got two things here. Write an inequality that represents the interval, and then state whether the interval is bounded or unbounded. Here are our problems. Those with notes don't need to write anything down. Those without notes would have to write at least a little bit of stuff down here. So don't try to write out word for word, but maybe just kind of highlight the important stuff. So A, like write an inequality. B, state whether the interval is bounded or unbounded. All right, so let's go for it here. I like these. I like numbers 2, 4, and 6 because it gives you one of each type. That's the cool part here. But before we go on, and if you want to put this in, that piece there, those are called, or interval notation. That's how we write interval notation. On the homework, sometimes they'll say write it as interval notation, sometimes write it inequality, sometimes they'll just ask you to graph it, or another way to solve it, graphing and interval notation, or graphing and inequality notation. So that's interval notation. It's INTERVAL, interval notation. All right, then we have the graph. We're going to graph these guys, see what the graph looks like, and then at the end we're going to put it into inequality notation. I'll let you catch up on the wording there. All right, so let's go with it here. What does this mean? So notice you have a number that you start with and then a number that you end with. So let's do this here. We're going to graph this guy. 2 is on the left side. 10 is on the other side. And so the graph, notice the graph looks just like these little pieces here. So you got a parenthesis that's around the 2, and you got a brackets by the 10. What does this all mean? It means the number that you want, or the interval that I'm looking for, is anything above 2 or anything that is up and including 10. That's what I'm looking for. So interval notation, what this says is this number here, this little 2, is always going to be smaller than the number over here. So this is kind of like your starting point along the y-axis or x-axis, and then your ending point. That's what you're looking for. Let me write this over, then we can kind of explain the whole piece here. So there it is. We went from interval notation to graphing to inequality notation. So notice the interval notation looks very, very similar to how the graph takes place. So we're saying this. We're saying the number that I want, or the numbers that I have, is anything that's above 2 Anything up to 10 and including the 10. So I am including the 10, I'm not including the 2 in this process. How do I write it? Here it is. You're going to say x is less than, 2 is less than x. 2 is less than x. And x is less than or equal to 10. Notice the smaller numbers here, larger numbers here, and notice your inequalities are always less than. In this place here where something is bounded, your numbers are always going to be less than on the interval notation. Okay, what is this? This is bounded. Bounded just means there's a starting point over here. There's a stopping point. There's a stop, a start, and a stop. That's it. Okay, next one. See if you guys can graph it before me. Go for it. I'm looking at -5 as my starting point, and then infinity as my stopping point. Okay, let's go with it here. So I'm going to put on -5 somewhere in my little chart, and I'm going to go with bracket. And if you guys remember, brackets are kind of like closed dots from algebra, and parentheses are kind of like open dots from algebra. That's the way we sort of change them up. Okay, so bracket -5 as my starting point, but then I go off to infinity, which means I keep on going and going forever and ever. So that means it just goes all the way out through the arrow. So make sure you have this little shading out all the way to the arrow. And then also make the arrow bigger. That's what we do. All right, how to write this? So x is the number that I want. X is going to be greater than, because notice our graph is going off to the right, greater than or equal to -5. So the numbers that I want are either going to be bigger than -5 or they may equal -5. That's what I'm saying there. Is this bounded or unbounded? This is unbounded because it's unbounded going off to the right-hand side. Okay, I've got one last one for you. I'll give you 20 seconds or so. See if you can do it before me. Go. Okay, at least make the graph of it. All right, let's go with it here. So let's see if my graph and your graph are close. So notice my starting point is -infinity, which technically kind of means I don't have a starting point. I go all the way from -infinity and I go all the way up to 7. I stop at 7 and I have a bracket that's going to have to face to the left this time. So notice no starting point. We all go all the way up to 7. So if that's the case, then what I do is I have a shade that's going off to the left and just make the arrows bigger. So what are the numbers I'm looking for? The numbers I'm looking for, x, the numbers I'm looking for are going to be less than or equal to 7. That's all the numbers. That's what the shade area represents. So bounded or unbounded? Does it definitely have a starting point and ending point, or does it go all the way through one direction forever? It's unbounded. It goes all the way through one direction forever, or at least one direction forever. Okay, I think we're good there. That was properties, that was notation. So then let's take a look at some basic understanding of inequalities. Exercise 7 through 12. Oh, that's right, I forgot. Let's do the matching of the graphs to the problems themselves. There you go. So I don't want you to answer it based upon the numbers. I want you to answer it based upon your understanding of inequalities. Good. So notice you can probably get these just by numbers alone. That's no problem. But this whole concept right here, x, all the numbers that I want have to be greater than or equal to 5. Which graph gives me that? All the numbers that I want, or the shaded region, is either greater than 5 or equal to 5. Agreed. It's F all the way down here, notice. It's unbounded going off to the right, so all the numbers that I want are either greater than 5 or equal to 5. That's that bracket. All right, next one. This one, notice it's bounded between 0 and 9 halves. So just a little bit, what is 9 halves? 9 divided by 2. 4.5, 4.5, yeah. So I'm looking for a graph that goes from 0 to 4.5, and then also bracket. Notice this little bracket at 0, bracket 4.5, and that is going to be good. So yeah, 9 halves is 4.5, and it is C. C should be the answer there. And some students do have some issues with the absolute value stuff. So I just want to spend just a little extra time on this, see if this makes sense to you here. So I'm looking for numbers that if you take the absolute value of them, those numbers are still going to give me something that's greater than 4. So let's try some numbers. You don't have to do this with me. Don't have to write this part down. But let's think this with me, okay? So if I have -5, if I take the absolute value of -5, will it give me my solution for that problem? Yes, it will. That's right, because -5, absolute value of -5 is going to be 5, and 5 is greater than 4. That's true. Okay, how about this one? I'm going to just kind of load up a lot of them here. So -3, if I take absolute value of -3, what is the absolute value of -3? 3? Okay. 3 is going to be greater than 4. I don't think so. That's a no. Okay, -2. If I take the absolute value of -2 as 2, is 2 greater than 4? I don't think so. All right, let's go to the other side. Let's go to the positive side. Is this true? Absolute value of positive 3 is 3, and is 3 greater than 4? I don't think so. How about 5? Absolute value of 5 is 5, and 5 greater than 4? Yes, that's true. So really what's happening here is yes, it's true for the first one. It's no for everything in the middle. And then yes, it is again true at the end. So it looks like it's true on one side, nothing true in the middle, and then true on the back end. What does that look like? That looks like this little part called A right over here. So notice -5 is true. We shade that in. -4 is not true, but anything to the left of -4 is true. So therefore that parenthesis there. So nothing true here. All would be no's. And then on this side, you could put in 5, you can put in 10, you could put in 20. It doesn't matter. But you're going to get true answers anyways. So anything that's above 4 would give you true answers. All right, let's keep on going. 13 through 18. Yeah, let's see if we can make it through most of this. Yeah, we could probably make it through most of this. Let's just plug in some values. Let's practice plugging in values themselves to see how this all works. So let's go with it here. So for 14, I have 2x plus 1 is less than -3. I'm going to plug in values for x. For a, I'm going to plug in 0 and just find out if this is a solution. We're going to determine whether these are solutions, whether it makes it true. If it makes it true, then it's a solution. So let's go with it. Let's plug in 0 right here. That 0 is going to go in for that x over there. So for a, it's 2 times 0 plus 1. Is that less than -3? 2 times 0 is 0. 0 plus 1 is 1. 1. I'm going to go show all the steps here. That's 1 is less than -3. That is... no, that's not true. 1 is not less than -3. No way. Not a solution. B. And again, we're going to do this for each one. Of course, the way I can make it more difficult is put in fractions. I can put in negative fractions. I can make this kind of difficult like that. So let's go with B. We're plugging in a -1/4. So 2 times -1/4 plus 1 less than -3. So the question is this a solution? Is this give me something that's less than -3 on the left-hand side? So let's go with it here. If I do this, let me just multiply straight across here. In fact, let me put in a pin. I'll make this into like that, right? And 2 times negative 1 is negative 2. 1 times 4 is 4, so I got my numbers there. And let's see, negative 2 over 4 makes a negative 1/2 plus 1, less than negative 3. And what is subtracting a half, adding 1? Or we can actually even say this, what's $1 subtract half a dollar? It'll be half a dollar. So half is less than negative 3. Is that true or false? Is 1/2 less than negative 3? And I'm going to say that is false. This also is not a solution. All right, let's try negative 4. Plug it in for C. Plug it in negative 4 for C. Go for it. See if you can stay ahead of me. See, 2 times negative 4 plus 1, is that less than negative 3, yes or no? So 2 times negative 4, that's going to be negative 8. Negative 8 plus 1 is going to be less than negative 3. We'll see if that's true. Negative 8 plus 1 is negative 7. Negative 7 is less than negative 3. True or false? Yeah, this time it's true. Negative 7 is less than 3. Good, there's my solution. So out of all these numbers so far, just negative 4 is a solution. D, and let's put this one in. This is a negative improper fraction. Let's see, negative 3 over 2 for the x. That comes in for the x's. Plus 1 is less than negative 3. True or false? Well, again, that 2 and that 2 reduce. So we're left with a negative 3 on top. Plus 1 is less than negative 3. Negative 3 plus 1 is a negative 2. Negative 2 is less than 3. Yes or no? Is that true? Negative 2 is less than negative 3. That is not true. Therefore, not a solution. All right. Hopefully that was useful as a setup there. So that is the beginning part here. So now let's start solving things. All right, 19 to 44, solve the inequality, and then sketch the solution on a real number line. So also remember that sometimes you may not get a solution. Kind of just depends. So let's go with it here. This is number 20. And these are going to be very basic. I want to show you something with these here. So think back to your days. If this was an equal sign, if this was 10x equals negative 40, what would you do to solve this for x? 10x equals negative 40. You would divide both sides by 10, right? Divide by 10 here, divide by 10 here. That's exactly what you do here. We're going to divide by 10 here, divide by 10 here. 10 divided by 10 is 1, so I just have x by itself. I bring down the less than sign, and the question is, Mr. Ngiev, why didn't we change it? Because we are dividing through by a positive 10, right? The number that we're using to divide both sides of the inequality is a positive 10, so the inequality stays the same. Negative 40 divided by 10 will give us negative 4. That is the final answer right there. So no need for a sign change or the change of inequality because we divided through by a positive 10. All right, let's graph it. Graphing, so make a number line, put one designation of negative 4, just kind of put it somewhere there. And also when you do this here, make sure that your shading and everything else occurs actually on the number line itself. Sometimes students put it above the number line. That's technically wrong. You should have your shading and your parenthesis or your bracket right on the line itself. So if you think about this here, this says x, the number that I want is less than negative 4. So x is less than negative 4. If I'm looking at a number line, all the stuff that's less than negative 4 is to the left right here. So I'm going to start shading. Ooh, hold on. Parentheses or bracket? If it's a less than symbol only, that means you got a parenthesis. If it had a less than or equal to on the bottom here, then that would have been your bracket setup here. So the number that I want is less than -4. It's going to be a parenthesis. So that should look like a parenthesis there. All right, and we shade off to the left. One more thing, very important to note, is when you do this here, always do this one extra thing. Make this arrow bigger. Just kind of fill in the arrow. That's what I want right there. Boom. So we solved it and we graphed it. There's your two different pieces. All right, number 22, which has already popped up over here. So the question is, what are you going to solve in order to solve for x? Or what are you going to do to solve for x? Yep, let's divide through by -6. We divide by the number that's next to the x. Since we're dividing through, oh, hold on, look at this. Since we're dividing through by a -6, something's going to change. And this little designation of mine right here, it's kind of like this little arrow that's kind of curled up and then still swung open. That would be my little notation that I'm flipping my sign. So -6 divided by -6 is a 1. Got that. We are switching our inequality because we're dividing both sides by -6. And this one, let's see if I can reduce this. Yeah, 15 over 6. 3 will go into those. Let's divide both sides by 3. 15 divided by 3 is 5. -6 divided by 3 is -2. And you can actually keep it just like that if you like. Oh, actually, no, we should probably either move the negative up to the middle of our fraction or put the negative on top. That's fine. If you want to, you can figure out what how many times does 2 go into 5? And then, so if you divide 2 into 5, you're going to get 2.5. Just don't forget it's a negative. If you're to graph it, here it is. Bracket or parentheses? Bracket or parentheses. X is less than -2.5. And it's going to be parentheses again because you're not saying less than or equal to, which means you're not including the -2.5. You just want things that are less than -2.5. That's what you want. So shade it in. What do we do with the arrow? We make it bigger and then shade it in as well. We want to see that arrow going out. Okay. The time remaining, let's go for it here. Same rule applies. So here it is. We just need to solve. That's what we need to do. So let's solve. So I'm going to put x's together on one side and then everything else on the other. So I'm looking, there are 2 x's here. There's a 3x here. There's an x here. So I'm going to let me erase this one. Let me get rid of this one by subtracting x from both sides. Subtract x, subtract x. Those are goners on the right side. 3x minus an x makes 2x. You bring down the 1. Greater than or equal to 2. All right, from here, I think I'm going to subtract 1 from both sides. Subtract 1, subtract 1. And I got myself 2x. Cancel off the 1 -1. They're gone. Is going to be greater than, or yeah, greater than or equal to 1. Yeah, 2 minus 1 is 1. Okay, one more thing to do. I'm going to solve it for x. I'm going to divide both sides by 2. And we're dividing by a +2. We do not flip the inequality. That stays the same. So x is greater than or equal to 1/2. Can we graph it? So all yours to graph. Give you guys 22-second head start. All right, graphing it, 1/2 goes down here, and let's see, it's greater than or equal to. That little equal to part right over here changes things up. So 1/2 is greater than or equal to 1/2. So that means there's a bracket there. The number that I want is bigger than 1/2, so that means my shade is off to the right-hand side. What do we do with the arrow? We make it bigger. Okay. There is that. So now let's get more complicated. Each one is going to get more and more complicated as we go. So now let's introduce you guys to fractions here. So take the time to write it down. If you don't have the notes in front of you, go for it. It's 3 plus 2 over 7x greater than x minus 2. So notice we have a fraction in our hands. So let's get rid of the fraction. That's what I want to do. So we only have one fraction. So the common denominator is just 7 because we only need to compare it to that single fraction. So let's do this. Let's multiply both sides by 7. So 7 multiplies the left-hand side. 7 multiplies the right-hand side. All right, as we do this, multiply the 7 to the 3 makes 21. As you multiply the 7 to the 2 sevens, remember that was the whole point. The whole point was actually canceling off these little 7s here. Is greater than, distribute the 7, 7 times x. 7 times negative 2, or minus 2, makes negative 14. And now let's do what we've been doing here. Let's put x's together on one side. It really doesn't matter which one you put it on, but traditionally in math, we just put it on the left-hand side each time. So I'm going to subtract 7x from both sides. Those guys are crossed out as planned. So 21 comes down. 2 plus 2 minus the 7 makes a negative 5x. Sign comes down. And then the leftovers here, in this case, the negative 14 has to come down as a negative 14 or else it's going to mess up everything. All right, what should we do to solve? I'm going to subtract 21 from both sides over here. That guy's gone. So we have ourselves negative 5x is greater than, let's see, negative 14 minus 21. 1 plus 4 is 5. Carry the 1. Yep, we're going to, since they're both negative, we're just going to add them up. 4 plus 1 is 5. 1 plus 2 is 3. Oh, right here we can divide now. We're going to divide both sides by a negative 5. And hopefully someone said it. You're going to have to change our inequality. So we got the little squiggly thing with a little arrow down to it. It just says, look, we've changed our inequality. So x is going to be flipping to less than. Now the negatives can go away over here. Negative and negative go away. So how many times does 5 go into 35? And that should be 7. Okay, can you graph this? Go for it. This should be easy graph. See if you can stay ahead of me. So 7 is right here. And we are going to go with, let's see, my number is less than 7. My number is less than 7. So that means it's going to go off to the left-hand side, not including the 7. So it's going to be a parentheses down to the left. What do we do with the arrow? Make it a little bit bigger, just fill it in. All right, we go from there. All right, that is good. Good job. So whenever we see fractions, let's multiply through. And we go from there. 34, a little bit different. So 34, notice it does have some fractions. That's great. Well, maybe not for some. But we have this little parenthesis that's actually multiplying that particular fraction. So here's what we're going to do. We're going to have to distribute. We're going to have to get rid of this first. We need this guy to be simplified as possible. And then we're going to see if we can need to multiply through by a common denominator. So let's do this first, and then we go back to what we did for number 30, 32. So let's go for it. The left-hand side, 9x minus 1, still stays the same. Everything's nice. It's a less than symbol. That's great. But off to the side, 3/4 times 16. So do that. If you can be ahead of your classmates, that's awesome. All right, over 1, and I can reduce stuff, right? 4 and 16 would actually reduce down to 1 and 4. Perfect. Notice the denominators are just 1s. So when you multiply this out, 3 times 4 is 12 over 1, or just 12. That's cool. That's good because we got ourselves a non-fraction answer over here. Okay, next one. We're going to distribute the 3/4 to the -2, this one. And again, we're going to have to do the same thing that we did over here. 3/4 times -2, or the minus sign. I guess we can write this. We can write the minus sign already part of my equation here. And then this itself is just going to be a multiplication. So by 2, we put a little 1 underneath the 2. Can we reduce anything? Can we reduce anything here? Yeah, 4 and 2 can reduce down to 2 and 1. Perfect. 3 times 1 is 3. 2 times 1 is 2. Okay, so let's scoot that little number all the way over there. All right, so notice this looks like number 23 now. I'm sorry, number 32 now. I have a fraction somewhere here. I'm going to do some stuff to get rid of the fraction. So let's go for it here. Common denominator is, anybody? 2. Yeah, that's the only fraction. 2 is in the denominator. That is the common denominator. So let's multiply both left and right by 2. 2 there, 2 there. So 2 times 9 is 18. 18x. 2 times 1 is 2. Less than. 2 times 12. Let's see, 12. That's going to be 24. Yeah, 24. 24x. And then 2 times that. 2 times the -3 over 2. So 3/2 times 2. So notice my multiplication is a little backwards, right? It's 2 times 3/2, but I'm actually doing is I'm multiplying 3/2 times 2. That's okay. 2's are gone. And hopefully you did that in your head because you knew the 2's are actually going to cancel themselves out even here. So that guy and that guy goes away. We're left with whatever's left on top, which is -3. Okay, let's, again, same exact problem. So we're going to go with subtracting 24x from both sides, get our x's together on the left, because we want to cancel that right there. 18 minus 24. 18 minus 24. 80 minus 4 is -6x. Minus 2 comes down. The sign comes down, and a -3. And notice the little minus has to go with our numbers here. Don't put a plus sign there. That little negative sign here is acting on the number in back of it each time. All right, with that, in order to get this guy by itself, we're going to have to add 2 to both sides. So -6x is less than -1, looks like. Okay, what do we divide by? What do we divide by? We divide by -6. And that already has a little alarm going off in your head, right? We're dividing by negative. We're using a negative to divide both sides. Ding, ding, ding. Gotta switch to inequality. So -6 divided by -6 is just x. Inequality has to be changed to accommodate the new measurement here. And then these negatives here are going to cancel themselves out. So -1 divided by -6 makes 1/6. Can you graph it now? All right, again, 20 seconds to catch up or 20 seconds to graph it, whatever you need. All right, and we are good. Let's go 1/6 right here. So the number that I want is greater than 1/6. So x is greater than 1/6. That's what the meaning of that is right there. So if x is greater as opposed to greater than equal to, greater than or equal to would have a bracket, but because it's just greater than, it's going to be a parentheses going off to the right. It's going to be a shading, and it's going to be a darkened arrow. Okay, so we got to 34 today in this lecture. Hopefully that went well. And I'll see you guys on Monday.